What was the effect again we're relying on? I keep wanting to say Bernoulli, but I know that's not it.
Bernoulli.
The what?
Is it Bernoulli?
Is
With
it?
the V?
No, Bernoulli's with a B. Well, it was something with a V, right?
Venturi.
Venturi.
What did I say? Did I say Bernoulli?
Bernoulli.
That's
Well, I
weird.
said Bernoulli, like,
I thought I knew.
Rattling off opera singers.
similar
I'm
thing.
gonna
Similar.
quick change the lights. So is that okay? Can I do a quick test change of the lights?
Sure.
Yeah, that's not gonna help. This is the best one.
And the forward, the forward ones you can leave on. They're not affecting the. It's good to leave the matrix burning. Forward LED can stay on as well. It's
The forward LED.
beyond the hole, right?
It makes it up a little bit brighter, but
Yeah.
You probably see it better without the light because the light's reflecting on the dust in the water. So
I learned that sometimes when you get them like at a different angle, it kind of like bypasses all that.
Dave's going to go check out the cameras.
Copy.
okay, here we go again. Oh, I touched the edge with the manipulator. Bad.
Wah, wah.
I think we're getting towards the point of diminishing returns on this hole just because the visibility is so bad. When I stick it in there, I think I'm basically guessing how far I go in. So
Seeming unproductive now.
yeah, I think we're diminishing returns here.
So we didn't really manage to change the size of that very much just now, did we?
We made it
I
wider.
I don't think so. It's, yeah, I can make it wider, but to go deeper is just I'm kind of guesstimating whether I'm going deeper or not.
Right. Yeah. Diminishing returns.
Diminishing returns, so. Yeah, it's, so we're basically almost halfway through our 8-hour dive, right?
Yeah.
So I guess it's a.
We don't really have leads on any of the other areas.
We can wait till it clears and try again. But I think poking around in there while it's mucky is not too effective.
If you widened it out, would it clear out a little better, or is this it?
It's hard to say, but it would take some time to widen it out. It's probably half an hour to widen it. Half an hour would. It's hard to say whether it would make it better or worse. So I was hoping the soil would kind of stabilize a little bit and stop sloughing. And
Yeah, it seems like the current's picking up loose sediment from the sides and just sweeping it across.
yeah, from the freshly disturbed.
Yeah.
At some point you would think it would
Stabilize.
stabilize, yeah.
Yeah. It's just so fine.
I don't think we have any other options, I'm afraid. When we got here, we found this site because it was, we had the disturbance on the seafloor from where the ROV had set down earlier. I think the pit was no longer visible. I think if we went off searching for other impact pits, I think we're going to find it. What do you think?
Yeah.
So yeah, we could keep dredging. Just we might be more effective to let it clear up a bit so we can determine what that we're actually dredging and not just pushing mud around in the bottom of the hole with the nozzle.
Right.
I could widen while we're waiting for visibility. If I widen on the downstream side,
it should.
It sounds like a good idea.
Yeah. See how we go there. Or it can knock dirt into the hole. Turn the lights back on, Mike, would you please? I'm convinced it's still. What do you think, upstream or downstream widening?
If you do it upstream, I think it's still gonna billow. It's just gonna go against the thing, and it has nothing. It might push it up. The current might push it up. Yeah, it might. It should. Because if you go downstream, it will kind of like diminish it, but then you'll get like a pocket where that dust ain't gonna go.
So we're gonna have less of a Bernoulli effect with our Venturi if we do it upstream or downstream.
Do it upstream the way you're doing it, and hopefully the current pushes the dust off the downstream side up and out.
So one of the questions sorry, yeah.
Oh, go ahead.
I was just going to say that one of the questions I've been asked was, after a meteorite's been sitting in the seafloor for 2 years, is it still scientifically useful? And the answer is yes. It'll be altered by the seawater for sure. It'll rust, but we being the planetary science community has become.
Sorry, Dr. Price, go ahead.
I was going to say that we work with meteorites from hot deserts and around the world and Antarctica on a regular basis, and they all show alteration to some degree. Some of these meteorites in Antarctica have been there for pushing up to 1 million years and have been wet. Obviously, the fresher it is, the better, but it's still useful to us. We basically identify the terrestrial alteration like rust and look past it, look around it. As long as there's a big enough meteorite left to be, something you can still slice open, then we can work around the terrestrial alteration.
So we're starting to get the next watch in here, and
Okay.
I'm gonna let it clear up for a few minutes as they come in so they can see what they're dealing with, and we'll spend a few minutes handing over to the next watch.
All right. Well, thank you very much.
Oh, my pleasure. Thanks for having us.
Yeah, thank you.
It's been the most informative watch of 2020 by far.
I know.
I hope I
collected
collected
4 questions.
I hope we collected like tons of cosmic dust. I hope the tailpipe is just stuffed full
It's
of
just like
meteorites.
Yeah, I'll be curious to see what that looks like, the exhaust magnet.
it's just packed.
Packed full. Actually, we got the bowling ball sized fragment actually ended up in there.
I don't think I'll be awake for the recovery.
Oh,
So I'm going to need to find that out afterwards.
I'm really wanting to fly up and show our tail to Argus and see what it looks like.
Oh, at 50 meters?
And
Just
then
be like, hold on, give us a second.
In this current, I could get away with it.
I didn't.
Yeah, it's
Yeah, we're, Dr. Fraser, we're working on it. We've got 2 of our video engineers troubleshooting it and talking with them directly, so we'll get them online soon, hopefully. Yeah, thank you.
I don't have it, no.
All right, so while the shift is changing out here, I'll give some background for those of y'all who are listening in on the Nautilus Live website. My name is Dr. Mark Fries. I am a planetary scientist at Johnson Space Center in Houston, Texas. I work in NASA's curation office, where we care for NASA's collections. And NASA's collections include the Apollo moon rocks brought back to Earth by the Apollo missions in the 60s and 70s. Material brought back to Earth by various spacecraft missions, to include the Genesis spacecraft and Stardust spacecraft. My task there is to care for the NASA Cosmic Dust Collection. The Cosmic Dust Collection is material from asteroids and comets, which rains down on the Earth, and NASA collects it with high-altitude aircraft. Basically, the Earth is acting as a large collector for a large volume of small material. There's about 30,000 tons of cosmic dust, which rains down on the Earth every year. And stuff is constantly filtering down slowly through the atmosphere. And we fly aircraft to high altitude and collect it before it mixes up with the dust coming up from the Earth's surface. So we take care of these collections and loan them out for scientific research around the world. We receive and process we are I will call back. All right, I think I can start up again. So I was describing what's going exactly what we're doing here, why we're looking at a hole in the seafloor. Again, my name is Dr. Mark Fries. I'm a planetary scientist and a curator at NASA Johnson Space Center. And the reason for this dive, in 2018, the 7th of March, 2018, local time, the local date, there was a meteorite fall in this spot. We are in the Olympic Coast National Marine Sanctuary off of the west coast of Washington State. And there was a meteorite fall that occurred here. It was observed by eyewitnesses. It was observed by seismometers. It showed up on weather radar as falling objects heading into the ocean, which is exactly why we were able to identify exactly where these meteorites fell. The meteorite fall occurred entirely into the ocean in fairly shallow depths here, all things considered. This is about 90 meters of seawater, and the Nautilus and its ROVs are capable of operating at much, much deeper depths than this, but there it is. That's where we're at. So a few months after the 2018 meteorite fall, the Nautilus made a transect along the site of the meteorites, the meteorite fall. Basically, it did a long straight survey along the bottom, looking for meteorite fragments. And what we found was that the bottom is far too soft for any meteorites to end up sitting on top of the surface. This is you looking at this hole right now. You can watch the, this hole is half a meter deep or so, and you can watch material just constantly falling into the hole off of the sides of the hole. It's just really fine, loose material that didn't do much to stop any falling objects. So Nautilus collected a series of samples here, and we took the samples back to Johnson Space Center, and there were no large meteorite fragments in them. So we basically sat, and I got to sit with a microscope, and I actually used a feather because feather ends up, I like to use a feather best. Some people like to use things like toothpicks or other little probes to move material around. And basically looked through all this fine sediment, grain by grain, patiently sitting for hours in front of this microscope. And over the course of looking at the material that the Nautilus recovered, found about 150 little melted samples, which have the appearance and other hallmarks of meteoritic material. Most of them came from this site right in front of you on your screen right now. There was in looking at the seafloor back in 2018, we found a circular pit on the seafloor. And it was about 60 to 80 centimeters across in diameter. And it looked like it could either be a spot where a meteorite hit the seafloor and embedded itself down in the seafloor. It also could look like an animal burrow, or something else was dropped off a ship and ended up in the mud or something. Anyway, we collected a sample out of it, and it turns out that of those 150 little pieces of meteoritic material, a good 70% of them came from this one sample right here. So it certainly appears that the evidence indicates that that circular pit was where a meteorite had plunged into the seafloor and left a bunch of fine material in the sediment in that hole. So the site was logged on with GPS along with the rest of the transect and all the sample collection sites, and now we're back with the ROV configured to dig. Basically, you can see in the right-hand side a dredge. It works on it's a suction device. Basically, there's the water's being pulled through that hose, and you stick the thing down in the mud, and it makes a hole. So we're back here to dig. We're back here to try to find the meteorite that's down in the mud. We don't know how deep it is. Hopefully it's not so deep that we can't dig down to it. We have brought along a large magnet for, this meteorite contains a great deal of metal. And the idea is we're going to dig down far enough that we can stick that magnet down in this hole and retrieve the meteorite. It is... The measurements I've done so far indicates this pretty good likelihood that this is an unusual type of meteorite. It is an iron-rich meteorite, more so than your typical meteorite, and so it's of special scientific value. Pretty much any meteorite is of scientific value, scientific interest. This one would be one of a fairly small number of meteorite falls of its type, if it turns out to be what the analyses of the tiny material indicates it is. So here we are. We are 90 meters down on the seafloor. The Nautilus's ROV has been digging the probably most exciting hole I've seen in 2020, and hopefully there's a meteorite at the bottom of it. And that's where we are. And right now the crew is changing shifts. The next one will pick up and start to dig into this hole further, and stick with us. Let's see what we get.
Morning, team.
Hello.
We all clicked in. You hear us?
You're muted.
You just flipped the far right flicky switch.
This one. Oops.
Oh,
Close enough.
gotcha. No.
Mask, microphone. Good morning, Mark on shore. Thanks for that. It was interesting listening to that. We're almost settled in here.
Can you hear me now?
Yes. Yeah, it was just this, the mute.
Gotcha.
Right. So you get this here. And that's all.
Up to listen.
Mm-hmm.
Good? All good. All right. Front row settled.
And this is your dream team?
That is my dream team.
So
Absolutely.
meaning mainly that we're still half asleep.
All right.
Good morning.
Morning.
Good morning.
So is that, who are we hearing? Are we hearing Mark on shore?
You okay with it?
Yeah, I'm all good with that.
You know what? That works better from here. So why don't you sit here?
You sure?
Yeah.
You Kim, do a mute before you switch over. Just have a pilot seat swap.
So while we're waiting, I want to say hi to anyone from the RV Falcor who may be out there listening. The Falcor also visited this meteorite fall site, excuse me, and performed a series of samplings with the ROVs, much like what we're seeing now, but without. So this is actually the third visit to this site, the second by the Nautilus, and first one was a few months after the fall, where we did a collected a series of samples in a transect through the strewn field. And then the second one was by the Falcor, collecting material and looking for sites where larger meteorites may have landed. And now we're back for the third and well, we're back for the third time to look at this particular site and dig into the seafloor and try to find meteorites in this find the meteorite which created the pit in the seafloor in this site.
All right. So we're just about set up here. So we're going to continue manipulating and dredging this hole out. Science, you want to go over the objectives? Science? Good morning, Science.
Good morning. Is that a question for me, the objectives?
Yeah, do you want us to continue kind of dredging here and widening this hole, is what I'm understanding?
Yes, so far we the last crew found the site where we're supposed to be digging and found basically the remnants of the excavation pit from 2018 and dug into it further. That's the hole you're looking at now. Got it far enough down to put the magnet in and did not get any meteorites out of it. And the plan at this point is to widen and deepen the hole and try again with the magnets.
Roger, understood. Would you be able to turn on that dredge there, Kim? Any particular area you want to widen or just all around?
All around.
Roger.
The problem that with the problem we're having is that the hole fills up with sediment, so you lose visibility digging. So they're trying to widen it a little bit to get more water flow down in there to see a little better. But wider and deeper, you know, we should be neatly centered over the hole right there. The center of the hole is the center of the old excavation pit, which should be in the right spot.
Okay, good to know. Thank you.
The angle of repose for this fluff seems to be pretty shallow.
Yeah.
Yeah, it falls apart on its own. It hardly needs your help.
So you want more flow in it, hey?
I dropped out there for a minute. Can you all hear me?
Yep.
Can do.
Okay. I'm in Houston, and we are getting some of the bands of storms from Tropical Storm Beta, and it's not bad, but might get some dropout.
We're all settled in. We could introduce ourselves. You guys good back there?
Yeah, this is Science. We're good back here.
Hi. Can everyone hear me?
Susie, Data, I did not hear you over the mic. Can you do another mic check, please?
Hello.
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 Cool. Thanks.
Good morning, Ed. This is Aaron Heffron, Navigator Seats. Jess Sandoval, ROV.
Kim Wallace, also on your ROV team.
You're a bit quiet, Kim.
Am I quiet?
Yeah, a little bit.
All right. I don't know how to fix that, but whatever. For the most part, I'm sitting here watching Jess dig a hole.
And good morning, Dr. Mark Fries. I am in Houston, Texas, joining in remotely from near Johnson Space Center. I'm not actually on site because we're all working from home these days.
And in the back row we have...
I'm Susie Cummings as data logger.
And this is Andrew Thurber on just sort of science person keeping an eye out, even though I'm not leading the dive. That's Mark on shore.
We have a few more science participants who are having difficulty logging in. It's been a little glitchy this morning. The second science, onshore science seat isn't coming through very clearly. There's Ralph Harvey at Case Western Reserve University. Ralph ran the U.S. Search for meteorites called ANSMET for, 3 years, I believe. Ralph is a longtime expert at meteorite recovery and identifying them, and a meteorite scientist. Also, Dr. Betsy Pugel from NASA Goddard is trying to log in. We will hopefully hear from all these folks later. And Jenny Waddell from NOAA. And Dr. Ryan Ziegler, also from Johnson Space Center. He is the curator of NASA's Apollo collection. And also Linda Welsenbach, who we may hear from later, who is a scientist and a science communicator at Rice University.
Yeah, it's really weak, which is unfortunate. Keep on trying to shake things out, maybe.
Yeah, it's
like it's
you know, the very fact that you're able to do this at all remotely is pretty astounding. We're all having to adapt to COVID, and the fact that you can run an entire scientific expedition from, with the scientists staying on shore like this is quite admirable, actually. So for those listening, let me, what you're seeing is just basically widening this hole and deepening this hole. The part that you can't see is, this is obviously a little water suction-based device there that's drawing in mud and material from the seafloor. On the exhaust end of it, the crew at Nautilus has attached a device that's full of it contains an array of rare, and it's basically back there to trap any small metallic meteorite bits that are getting sucked up here. So we'll collect anything that's removed from this pit and is and then examine it afterwards.
Would you mind putting an eye at the bottom of the hose with the bubble cam? Just so I know if I'm extending it too far out. Great, thank you.
Uh-oh. A visitor.
Sorry?
We have a visitor.
Got dinner. Little midnight snack there. The lemon, some butter. Oh, oh, that's a nice one too. So the hmm. So the giant magnet that's in the front box, did that get sent to us from Mark? Do you guys know?
Yes.
Yep.
Yeah, the meteorite fragments we've collected so far have a great deal of iron in them, and they should stick to that. Any meteorite pieces down this hole should stick to the magnet as long as we can dig down close enough to it. We don't really have a good handle on how far into the sediment these meteorites would have wound up.
Right.
So we are guessing.
Is that magnet something that's been used before, or did you guys come up with it for this?
It's it has not been used before. You know, magnets have been used before. So the backstory is last time Nautilus was here, we used a simple array of little rare earth magnets bolted to a piece of plastic, and stuck it down into the sediment in the hopes that we find a little piece of meteorite would stick to it. And what we found was, as soon as you put the magnets down in the soil, or down in this seafloor sediment. And you put the thing down there and turned it over and looked at it, and the magnets had just turned black. And it turns out that the sediment here has a large proportion of.
I think you cut out.
Just lost you, Mark. Oh, it did. Yeah, should get him. I think they're talking. Oh, I can't really hear you too well, Kim. Sorry.
So we seem to have lost Mark Freeze in Houston.
Yeah, we seem to have lost Mark. You guys got it? Okay.
Sorry,
He's right here working on that.
Not sure what happened. This may be another satellite glitch. He's back now.
I'm back. I am.
Welcome back. So last we heard is the magnets were black.
Yes. Okay.
Little
So
quick.
the okay. Sorry about that. Lost the signal here. All right. Here we go. All right, I'm back. So, yeah, the last time Nautilus was here, we used this tool. It was an array of magnets attached to a piece of plastic, basically, and stuck it down into the sediment here in the hope of picking up any little pieces of meteorite. We thought we'd just kind of tap this thing in the seafloor as we go and see what we could collect that way. And the first time we put it down in the sediment, we turned it over and looked at it, and it was just black from little tiny pieces of magnetite, little grains of magnetic iron oxide that are already present in the seafloor. It's not from meteorites; it's naturally occurring in the sediment. The sediment is weathered from all the lava rock, the basalts in western Washington State, and so just taking a magnet and putting it in and sticking it into the sediment here won't work. So the magnet that we have on the front of the ROV is a large switchable magnet, and by switchable, what I mean is it actually has an actuator in it where it's a magnet in a box, and the magnet moves inside the box when you actuate it. And the idea here is we will stick it down into the sediment to try to retrieve large pieces, and in order to get all the magnetite off the front of the thing, we'll actuate and release the material off the front of it. And we're going to keep that because it'll also contain little bits of meteorite, which I can study. But so to answer your question, yes, we've used a magnet before. This is a little more sophisticated way of going about it because it turns out that just sticking a magnet in the sediment is not going to work. So it's a fancy magnet. It's a switching magnet. It's a magnet with moving parts.
Oh, cool.
Mark, has any bright spark done a computer simulation, like given the supposed or imagined size of this thing? If it hit the ocean and, 'and, 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 ' how much velocity it would have when it got to the seafloor?
Well, we tried that. Problem is, there's a range of variables there that are not as well constrained as we like. The density of the meteorite plays a role. The size of the meteorite plays a role, and so we did do a set of calculations to try to figure out the size of the rock that would make the size of the pit that we saw in the seafloor here, and we came up with an answer that ranged from 50 pounds to 500 pounds, which is not terribly useful. I don't believe the 500-pound end of it. I think we're looking for something more like 50 pounds, which would be smaller than a bowling ball.
Oh, really? That tons?
Yeah. Definitely not a grand piano size, though.
I'm guessing like it would have broken up. There's a number of different sites.
Yeah. So the original meteoroid, the body that hit the atmosphere to create this meteorite fall, we have an estimate for the size of it that's about a sixth of a meter across. That comes from an infrasound measurement. There's basically infrasound measurements sensors scattered around the globe for watch. They watch for a variety of things. There's a bunch of science that can be done with infrasound. Infrasound is very, very long wavelength, deep, very bass sound. It's actually too far into the bass to be detected with human hearing. But because it's such a low, deep sound, it travels long distances around the globe, and so these sensors can pick up and get a estimate of the size of the object that creates a fireball. So anyway, we have this mass estimate of an object that is about 60 centimeters across when it hit the atmosphere, and that'll break up into a bunch of different pieces. They were scattered over what's called a strewn field. They basically it doesn't all fall neatly in one place. They can tend to get scattered over an area on the ground that's called the strewn field. And what you get is a small number of largest pieces and a large number of little pieces. The little pieces are relatively easy to find. Like I said, we got 150-ish of them out of this event, but they're so small that they've been completely melted. And that makes it a little tricky to sort out what kind of meteorite this was to begin with. And we're hoping to get a larger piece out of this pit so we can say we have a unmelted piece of the original meteorite fall to do research.
A question there for you, Mark. So kind of the objective right now for this dive, we're riding this hole. We're going to re-stick the magnet down into this hole. Then just kind of looking at time-wise, what other objectives do you foresee within the next 2.5, 3 hours? I guess, sorry, 3.5 hours.
So the first objective was to dig this hole. And the second objective is, if we can finish up with this, then to move due north from here and look for any more little impact pits from where meteorites landed in the seafloor. That was the plan. Plan A, plan's got problems. The problem is that when we found this site, when we had a GPS coordinate for this site from the previous Nautilus dive here, and when we returned here, the only reason you could tell that it was here is from the disturbance on the seafloor from where the ROV sat down the last time. and you could see the little trench that had been dug, but the original impact pit, we couldn't see it at all. So problem is, if we go hunting for more impact pits, I think they're already gone. I think they have been buried by the rain of sediment here and erased by the movement of currents. And we were kind of lucky to find this one. I don't think that moving anywhere is going to be productive. So I'm sorry to be rambling, but
No, that's
basically
great.
the objective is to stay here and work on this, because I don't think we're going to get anything anywhere else.
That's great. Thank you. So that sediment's, it's going through our system, right? And then it's going through the net at the end, the mesh net. And then, so are we piling up a big pile of sediment behind us? Would it clog on the back end or anything?
The way the cage is around the exhaust, it's not a tight fit, so that if the cage does become significantly clogged, the flow should continue around the end of the hose and back out.
Okay.
That was the theory.
That's the theory. If only we could see in Argus, we would know if we had a giant pile of sediment behind us.
Given how flat it is, and the fact that we're not actually going anywhere, it might be reasonable to bring Argus down a bit.
Hi, this is Dave. This is a test on SPL. Can you hear me?
Yeah, loud and clear, Dave. Yep.
Hello, SPL. Check 1, 2.
Hello.
Can you hear me?
Yes.
So everybody's okay to bring Argus down a bit? I don't think we're going to see anything.
Yeah, sure. I think so. I think your delta is what, 10 meters, 14 meters? 13, yeah.
It stopped at 10.
Roger.
I'm going to be